All right, let's get into it. Today, we're pulling back the curtain on the hidden architecture that makes so much of our digital world tick, microservice design patterns. And really, this is all about the art of the trade-off, the tough, clever choices that software architects make every single day.
So, have you ever stopped to think about this? It's Black Friday, or a huge new product just dropped, and millions of people are hitting the same app all at once. How does it not just fall over and die? It seems like it should, right? Feels kind of like magic.
Well, the secret sauce, the thing that makes it all work, is an architectural style called microservices. The big idea is, instead of building one massive, clunky application, you build a bunch of small, independent services that all work together. It's a design that's built from the ground up to handle enormous scale and to not panic when things go wrong.
But, and you knew there was a but coming, all that power and flexibility comes with a price tag, and that price is a ton of complexity. So, the real question isn't what are microservices, but how on earth do architects manage all that complexity? Well, that's exactly what we're going to unpack today.
Okay, first things first, we've got to talk about the most fundamental problem, the data. I mean, if you have hundreds of these little services all running around, how do they store and get the information they need without just constantly bumping into each other and making a huge mess? Well, the simplest way to do it is what's called the shared database pattern. You just have one big central database and everybody connects to it. Super simple to get going, right? And keeping data consistent is a breeze. But, and this is a huge but, it's a terrible idea in the long run. That one database becomes a single point of failure. If it goes down, everything goes down. It becomes a massive bottleneck, and it totally kills the whole point of microservices, which is to be independent. So, to fix that, the standard today is the database per service pattern. And the rule here is just beautifully simple. Every single microservice gets its very own private database, and nobody else is allowed to touch it, period. It enforces that independence we were talking about.
And this is where you unlock the real power. Because now you can scale each service and its database totally on its own. If your user service is getting slammed with traffic, no problem. You just scale that part up without ever touching, say, the payment service. It makes load balancing and creating backups so much easier. This is the key to achieving that mind-boggling scalability.
But look what we've done. In solving one really big problem, we've created a brand new one, and it is a real head-scratcher. Think about a simple customer order. That might need data from the user service, the product service, and the shipping service. How do you possibly coordinate one single action across three totally separate databases and make sure it either all works or none of it works?
Well, the answer to that very tricky puzzle is another powerful design pattern called SAGA.
A SAGA is basically a sequence of local transactions. Think of it like a super high-tech relay race. The first service does its little piece of the job in its own database, and then it fires off an event, like passing the baton. The next service is listening for that, catches the baton, does its own work, and then passes the baton again. And on it goes.
Now, there are two main ways to run this race. The first is called Choreography, where all the services just talk directly to each other. It's decentralized, which is cool, but it can get really tangled and messy pretty fast. The other way is Orchestration. Here, you have a central manager, like a conductor for an orchestra, that tells each service exactly what to do and when. It's way easier to keep track of, but now your conductor is a single point of failure. See? It's another classic trade-off.
And here's the real kicker with the SAGA pattern. If you're 5 steps into this process and step 3 suddenly fails, there's no magic undo button. Nope. The developers have to manually, by hand, write extra code to reverse every single step that came before the failure. These are called compensating transactions, and believe me, they add a whole new layer of complexity.
Okay, so we figured out how to handle our data consistency. But let's talk about a new problem. What happens when one of your services just stops responding? It just goes completely dark.
This quote right here just perfectly nails the philosophy behind our next pattern. I mean, it's just common sense, right? If you know a service is down, why on earth would you keep asking it for things? It's like knocking on the door of a house you know is empty.
Every single one of those pointless requests wastes CPU cycles, it wastes network bandwidth, and even worse, it makes your users sit there staring at a loading spinner, just to eventually get an error message. This is how a cascading failure starts, where one little broken service can take down your entire system.
So to prevent that, we use the circuit breaker pattern. It works just like the circuit breaker in your house. Normally, it's in the closed state, and all the requests are flowing through just fine. But if it starts seeing too many failures, Bam! It trips and goes into the open state. Now it just fails all new requests instantly, without even trying to send them. After a little cooldown timer, it moves to a half-open state, where it lets just 1 or 2 test requests through. If those work, great, it closes the circuit. If they fail, it stays open.
The benefits here are huge. You stop those system-wide meltdowns before they can even start, and you save a ton of resources. But you guessed it, this introduces a brand new question for the architects to answer. When that circuit is open, what do you do? What do you show the user? Do you try again later? Show them some older, cached data? Getting that fallback plan and the timeout value just right is absolutely critical. So, as we start to put all these pieces together, you're probably noticing a theme, right? Every single solution we've talked about is a delicate balancing act. And this table just lays it out perfectly. It's this chain of cause and effect. We use database per service to get rid of bottlenecks, but that creates a data consistency problem. So we use the SAGA pattern to solve that. But that introduces the nightmare of writing compensating transactions. So then we use circuit breakers to stop services from failing. But that forces us to figure out a fallback strategy. It's always one problem, one solution, and one new, more interesting challenge.
So here's the real takeaway. Microservice patterns are not about getting rid of complexity. They are tools for managing it. They give architects the power to build these incredibly tough, unbelievably scalable systems by making very deliberate, very thoughtful choices about where they're willing to accept a little pain in exchange for a lot of power.
And that really just leaves us with the ultimate question, doesn't it? Now that you've seen the tools and you understand the trade-offs that go into taming all this complexity, when is it actually worth it? When should you take on this challenge in the first place? And that, right there, is the multi-million-dollar question that every architect has to answer.